Oh, I have the camera on there and I'm screen sharing here. Yeah. All right, looks like it's you're missing a couple of people, but his hello. Yeah, just when you're ready, you can go to that table. That one. Right? Oh, you didn't see it? Oh, good. Right. Right, okay. Guys, yeah, if you can go and grab an Arduino, the breadboard. Quickly on Arduino, get to LED. Yeah. Yeah, get anyone not have jumper one? Did anyone here come in a group? Or what happened? Oh, who's in your group? Yeah, I'll just agree on that. Before we begin, can we just go around saying each other's names just to familiarize with your competition for this week? So first of all, I'm Michael and I'm the Vice President of MUEC. And yeah, so do you want to start from Thompson? Yes, great. Nice to meet you. Nice. You want to go from the back? Nice, nice. That's your sign? Oh, yeah. Oh, what's your name, sir? Oh, Nick. Nice to meet you. Paddy, was it? Oh, Addy. Okay, yeah. Oh, great. Okay, so everyone's bachelor's. Perfect. Yeah. All right, welcome to Arduino Crash Course. Go to the next slide. Okay, so has anyone used an Arduino before or any kind of electronics? You have. What's the experience like? Yeah. What do you guys? Yeah. Yeah, yeah. Okay, so for anyone who hasn't used it, Arduino is basically basically a programmable electronic. So you can connect up hardware to it through all these like what do they call ports? Pins, yeah. And you can put in C code and you can run it in there. It's basically a mini computer. So that's the hardware, and then you put in code. Yeah. So these boards can read input, so you can send in voltage signals to each of these pins, or for some of them, and then from the others you can output voltage level. Yeah. You can do things like create a motor that you can do today. Turning on an LED, which will also do today, and then probably something on that. So that's a bit more complicated, but you can do like advanced projects with Arduino, whatever you want. Yeah. And then we have breadboard. So this is where you're going to connect up all your electronics. So how breadboard works is you have all these like lines of pins. So on the outside, if we look at these two, hello, welcome. You can see, you can grab your breadboard and see, you can see like the red line and there's next to it, and the blue line with pins next to it. So these two are the power and the power rails, and all of these lines in the vertical direction are all connected. So if you connect up a pin over here, if you connect up any kind of electronic here, that same voltage level can be read in all of these other pins. They're all electrically connected. And then same with this line here, but usually you connect up any of your power, your input voltage into the red pins, and then your ground to the blue pin, same on that side. And then these ones in the middle, they're all separate from the outside, but they're not connected vertically. Instead, they're connected horizontally. And then there's a separator in the middle as well. You can see the lines connected there. And some circuit essentials. So this is how an electric circuit works. Okay, yes. So very basic setup of a lamp. So we have a battery. So today we're going to be using the Arduino to power the circuit. So your laptop. Oh, yeah. So your laptop. So you don't have a battery. Your laptop will basically act as a battery and provide power to your Arduino. Yeah. Arduino will be able to output voltage, and you connect it up to a lamp. So in this case, we've got the LEDs for you guys to use, and it completes the circuit. Yeah. So the battery has a voltage which will be applied across the lamp, and then this will also bring current going forwards this way. And when that current passes through the LED, it should light up. Yeah. And because it's a closed circuit, the current just goes all the way around, and go all the way around. If the circuit is disconnected anywhere, the current has nowhere to go, so it'll stop working. And so the setup. So we have to download the Arduino IDE, which is where you're going to be coding the Arduino. So an IDE stands for Integrated Developer Environment, which is basically it's basically a text editor, but it's suited for the specific type of code and that you're going to be using. Yeah. So let's download the Arduino IDE. So if you go to Google, if you don't have it downloaded, go to Google and search up Arduino IDE. Does anyone have a Mac? No. Go ahead and plug in like this. If you have a Mac, and you don't have an adapter, you can plug in. Yeah, when you search it up, you get this. So click on the first link, and then you'll see this window. Just go download Windows 10 and newer 64 bits. This one here. and then follow the prompts on the screen. After it downloads, just open up the installer and then just click next over here, and then it'll do the installing, and then a desktop shortcut will appear.
Just yell up when you have downloaded it, and yeah, we'll wait for everyone to get ready. Yeah. And just shout out if you need any help as well.
Put this in at the end. Feedback form and this.
Oh yeah, okay, thanks. Wait, so who's actually downloaded already? Oh, nice, okay. Yeah, okay. We'll just wait a bit more.
Are we going to wire it up?
Oh, yeah, let's do it.
Yeah.
Is anyone coming to the hardware teardown tomorrow? Either.
The e-waste teardown.
So tomorrow we're getting some e-waste and like breaking it up to use for WhatHack. Because yeah, so for WhatHack, there's going to be a lot of recycled electronics for you to use to connect to the Arduino as well.
So we have a couple of printers and telephones there tomorrow.
I'll grab it.
Switch.
Is it? Oh,
you step on it.
Oh yeah, thanks. Oh yeah, good point.
How does it work? You said there was a problem, right?
Huh?
There's a problem with Arduino IDE on the outside.
I think so.
Oh.
Wait, what is it called?
IDE.
I don't even know if I have it. I might not have it. What's it called? Oh, it's in a folder, isn't it? Maybe I just uninstalled it. I should have one installed. Should I install it? Yeah.
Yeah. The pizza pickup with that 6:30 or something.
Okay.
After we do the workshop, we'll have a couple of people here and then we go and cut the pizza.
Oh, good point. Yeah,
Yeah.
sure.
So the workshop will hopefully go for like about an hour and a half. And that's it. We're already 20 minutes in, so.
But who hasn't installed it yet? Okay, so everyone's good? I haven't installed it
You
yet.
can go ahead. Yep. Can everyone see this screen? Maybe it's like white on your side.
Oh.
Yeah. So when you start on a brand new code, like brand new file, you have two functions that are set up like this. Oh, just a question: anyone coded in C before?
Who hasn't?
Who hasn't coded in C?
Oh, everyone's
Oh,
experienced.
everyone's done.
Nice.
Okay, that's good.
Perfect.
Yeah, so Arduino is mostly C. It's like a C and C++ combination, but it's very intuitive. So yeah, you have two basic functions, setup and loop. So setup runs once when you run the code, and loop just keeps repeating over and over. So that's the basic function. So when you press start on your code, there's the setup one, it goes to the loop, and then it just does that over and over again. And that's your code. Okay, break time. If anyone has any questions so far. An Arduino, one of these. Yeah, like a brand new one. Well, if you were to buy it from the Arduino brand, like the actual Arduino company, it's like $20-25. But there are other companies who make clones or like fakes, and they work basically the same, and you can grab them for like $10. Yeah. Yeah. So this is the Arduino Uno R3, and they recently, like a week ago, they released the R4, which is the next one in line. Yeah, and it apparently has more functionality. Yeah. Okay, let's move on then. So safety. If you are if you're like unplugging or putting anything into your breadboard, if you're plugging something in, make sure to unplug your Arduino from your laptop, because if it short circuits accidentally, then something bad could happen to your laptop. And if a short circuit does happen, you might notice that some components get really hot. That's because why is that again?
There's lots of current, which
Yeah.
means there's a lot of power loss.
There's like a lot of
energy.
current just flowing in the same
Yeah.
spot, and so it gets hot. There's a lot of energy there. But we are working with very low voltage. So Arduino's only use 5 volts. So even if you get electrocuted, nothing's going to happen to you. Yeah. But just in case, just unplug your Arduino from your laptop. Just take the USB port, like the cable out, anytime you're changing anything on your breadboard. So the first component we're going to be looking at is the LED. So you can explain what it's about.
Oh, yes. Okay, so the LED has a long leg and a short leg. Can everyone see that on their own LED? Oh. So an LED emits a light when there is current that flows through it in the correct way. Yeah, so what does it say? Yeah, so the larger leg is the positive side and the shorter leg is the negative side. Yeah, so if you have enough voltage applied across it, so you want enough positive voltage on the positive leg, then the light will emit. But if there is not enough voltage, or if the voltage is applied backwards, then it will not light up. Yep, got that? Or if there's a open circuit, as explained before.
Okay. So this is the code for the LED. But before we do that, let's plug the circuit up.
Yes.
So grab your breadboards and your wires and your LED and your resistor, and then connect the wires, or make the, what do you call this, circuit? Yeah, yes. Make the circuit as shown.
Yeah. This is the longer leg, by the way, the one that's a little bit bent on the diagram. don't have one type of jumper cable. So you should have a pointy metal end, both end on both sides. So metal cable. You don't really know. No, you can go. Huh? Oh, we need. Does anyone know why we would use the resistor in this case as well? Yes, to limit the current flowing through the conductor. So we want enough resistance.
Why do we have to limit it?
Huh?
Why do you have to limit the current?
So we are using current that we know how much it is. Yeah. So yeah, so everyone make sure that the positive, the longer end is next to the resistor. Yeah. Has everyone done it that way? If you don't, your light won't turn on. So yeah, if that happens, then maybe switch it around after. Okay.
Oh, okay. Write the code first.
You want to go to the code page for everyone?
Yeah. And then everyone connected their circuit. Okay. So now just type in this code.
And we'll explain it in a second.
The lines after the double flashes are just commenting. So just to help you understand what's going on.
Explain the code.
I'll explain after everyone's typed it up.
You got it? You want me?
You can do it.
My Arduino is open.
No. What are all these things like papers on the desktop?
Just a bit messy. I'll restart. But yeah. Next
Restarting. Yeah, I'll probably is the code. Can I just copy it? Yes.
Okay, so while you guys are typing and finishing up, I'll just explain what this code does. So we have int LED equals 13. So we put that in because 13 is the pin we're using. So if you look at the Arduino, you have the wire connected to the 13th output. Yeah, and LED is just a name of variable that we're calling. Okay, so in the setup, so this is the thing that runs once we start the once we run the program. We have that the pin mode of the LED is the output. So what this means is that LED, which is the 13th pin on the Arduino, will act as an output. So it will be outputting 5 volts, which is what we want. Okay, so now we go to the loop, which is the part that runs forever. Digital write makes the output pin 5 volts. So we write digital write LED high, that means we're going to be making the output 5 volts for the pin 13. And then we have a delay of 1000 milliseconds. So its base is in milliseconds. So that's why I write 1000. And then we go write digital write LED load to put it back down to 0. And then we delay for another like 1000 milliseconds. And then it repeats on forever. So what do you think will happen to the LED when we run this code? Yeah, so it'll be flashing on and off. Yeah, so if you guys want to, how do you run it again?
So after you type in the code, you can plug the Arduino in and then click on the run button, which is on the top left.
Oh, perfect. You guys want to see an example? It's
We have
oh,
we have it here.
yeah.
That's why
You guys gonna work?
So you can try changing the delays and see how far we can get with it. Can you see? Does it look like it's blinking to you?
Yeah.
See, what about now?
Are you seeing what the refresh rate?
Yeah.
Eyes?
Can you?
Yeah.
You can.
You can, right? Yeah.
This, I bet you can't see this one.
Oh, it's just flickering.
You can see that it's
Yeah.
flickering.
You can't? What do you mean? You're looking at
I
it
can,
too?
yeah.
Yeah. Yeah. Do you want to move on to the next slide? Right?
Oh, now. All right, let's move on then. Okay, so next we're gonna look at the button.
So you guys will know which component it is? It's the very little one. You should be able to press it. It's pretty like you make a quick sound. Yeah.
So you can see there are 4 legs, right? So you can from this, like A and C are connected, and B and B. So it's connected vertically.
Yeah, so when you first put the button in, it will act as an open circuit. So there's no current flowing from this side to this side until you press the button where the switch will close, and then you'll get current flowing. Yeah. So next slide.
Yeah. When you press the button, So when you haven't pressed the button, none of them are connected. But when you do press the button, A and C get connected, and then B and E also get connected. So you basically have two lines that you can work with. So this is the code for that. But first, let's wire up the circuit. So don't take anything out of your breadboard. You're just putting the button in and the extra wires in. So you're just modifying it. All right. Can you plug it in? Unplug it.
Wait, go back. Got a resistor?
Yeah.
Oh, yeah.
Didn't do this.
I don't know. There you
You don't know who he is.
go.
He's a dean of he's the dean of here. You go to lunch with him. We got an invitation.
I don't know. Sure not. Wait, I don't know.
Wow.
Wait, when?
Really fun.
Maybe if you go.
And thank him for all the kid funding.
Oh, yeah. I think that's it. I don't know. Close enough.
Please.
We didn't put the code in. So.
I did.
Oh, you did? Well, okay.
Magic.
Oh, that's right.
Does everyone be able to plug it in? From the Arduino, now you're connecting into the power pin, so the 5-volt pin. Then you're connecting it directly to the resistor. Then from the resistor, go into one of the digital pin, and that is going to be input. So that's going to be,
I don't remember.
yeah, that's going to be,
Oh, yeah, it is. Yeah. Yeah.
yeah, that's basically going to connect yeah, that's going to see if the button's pressed or not. Green one. Yeah.
Wait, well, let's let you guys write up the code first, and then we can go
Yeah.
through it.
So it's the same code as last time, but modified. So you don't need to start a new file or anything.
Okay, so I'll begin explaining what this code does. So we have an extra pin this time, pin 12. And this will be an input pin instead of an output pin. So what it does is it reads what voltage is being placed. So it's like a scope. If you guys have used the 82 before, some of you guys, yeah. So it will detect what voltage is there. So at the start, we set up the pin mode for pin input pin is input, and then the LED pin is output. Yes, so that's 12 and 13. And then once we start the loop area of the function, what it will do is it will read the voltage at the input. Wait, can you like switch back to that one?
Yep.
I don't know how it works. Okay. Okay, so in the loop, the pin state will read what the voltage is at the input pin. So it will read it here. So if the switch is acting as an open circuit, that means no one's touching it. That means we have a 5-volt here connected to here. And then this goes all the way back to pin 12. So that completes the circuit. And what ends up happening is that all the voltage is going across this resistor because there's no other components, right? And then that means what this will be reading is a very low voltage of 0. Yeah. So when the pin state reads a 0 voltage, this will mean that the button is not pressed. So the button actually works backwards. So a low voltage will mean it's a true reading, and a high voltage will mean it's a false reading. So when it reads 0 voltage, it will read a true reading. And then if you press down on the button, it will complete the circuit. So the current is able to flow across into the diode. Wait, into this resistor, into the ground.
Through the LED.
Wait, sorry, through LED into ground, yeah. So what happens is that you'll be getting a higher voltage value at the reading. And we have an if statement here. So since you guys have all used C before, it should be pretty familiar. So if we read that the pin state is true, so that means the button is not pressed, then we digital write the LED pin to low. So we make sure that the light stays off, just like in the previous exercise. And then if anything else, so if the pin state is equal to false, then we will rewrite it as LEDs high. And then we have a 1 millisecond delay. So this will keep refreshing every millisecond. Yeah, so if you guys want to try and see what that looks like, and after you run it, it should work in terms of if you press the button, it should light up. And once you take your finger off, it should stop. Let me know if anyone needs to look at either screen and we can switch. Yeah. Hold on. So when the button is pressed, this closes. So the path go like, and then it will click. I think there's just like a voltage drop across here as well, which means that yeah. So like there's a lot of voltage that's here because you know how this is the positive of the diode, and this is negative. So current can't actually flow through the diode this way. So you'll be holding a lot of the voltage right here, which means that the reading here is going to be a lot lower. That makes sense because the 5-volt has to be split across this resistor and the diode. Whereas if you have the open circuit, all the voltage is across here, which means this is going to be low reading. But if it's going through the diode, then this is going to have like a voltage here. There's going to be a low voltage. Actually, there's only no voltage here. Well, smaller voltage anyway. So then this reading would be high. And then that gets you to the other part of the circuit. Sorry, do you want me to explain any part of that again? So right now it looks like this, it's short circuit like that. But then when you press it down, it will connect this way as well. So it will connect, yeah, like this. I'll get back to the old slide. I can get to the slide again. For that. so right now, when you put it in, these are connected, legs are connected, but they're not connected this way. So once you press the button in, it will like close like a switch, and then you'll be able to go through the path going to the diode. If that makes sense. Yeah. Okay. Good. Oh, yeah, can go to code. Has anyone got it working yet? Nice. Oh, yeah. Okay. I'm not gonna. Actually, I'm doing my third. Yeah. Yeah. Has everyone got it working? Okay, I think that's everyone. Oh, never mind. Right, so is he still on?
Yeah, no, it's all good.
That's all good? It's all sorted? Perfect. Okay. I want to apologize for my explanation earlier because I was a bit mistaken. So to redo everything, to get everything I said before. Oh, actually, some of it, right? Anyway, so yeah, so this is ground here. So when the switch is not pressed, there's an open circuit here, which means that the 5 volts will be across the open circuit. Oh, sorry. Yeah, so there'll be 5 volts across here because this acts as a path of a lot of resistance. So when you're not pressing it, it'll be 5 volts. Then that will be a low reading. Then when you press it, it will be short circuited. So all the voltage will go across the resistor, and then there'll be no voltage reading here when it goes back to ground. Is that more clear? Sorry about that. Let me know if you need me to explain it again.
Let's go to the next. Oh, we have another break in Q&A session.
Yes.
Any questions?
Does everyone like the LED? Yeah. Maybe you can work that out. Yes.
Where to do the button and LED? It's because of the resistors, that's why it's so complicated. Yeah.
So then, does anyone have any questions? Or no?
Yeah. It looks complicated because it's on a breadboard. If you were to just like connect up the wires to each other, then it will be just like a circular circuit.
True.
Yeah. But breadboards are usually used for prototyping. So if you're not sure, or if you're trying to build something, you can basically experiment on the breadboard. And once you're sure like that it works, then you can go to a proto board, which is where it's like a. Do you guys know what soldering is? Yeah, it's basically you're like connecting up all the wires using like what is solder? It's like you're basically like melting metal and you're connecting up all the wires to each other. So you can do that, and then once you're like 100% sure that it works, then you can make a printed circuit board, just like those green things inside electronics. So you can design that and then get that printed, and then that's set in stone. And then that's what they do for like any kind of like mass manufactured electrical equipment, like a computer, for example. After they know it works, then they just need to print like thousands of it. Yeah. Next is the potentiometer. This is basically a variable resistor. So right now the resistors that you use, they're all 220 ohms. Those are just like constant values. But then with the potentiometer, you can rotate it and it changes the resistance. So that means you can let more or less current go through your circuit. So when you do it, apply to an LED, you can change the brightness of the LED, because if there's more current, that means there's more energy being input into the LED, and so the LED will become brighter. Yeah. Yep. Next is this is the code that you're going to be using. But for now, so just plug in your potentiometer. Yeah, you're taking everything off and then starting over. So you're not doing the brightness. Yeah. Oh, no, here. Yeah, there it is. This. So we just did this. Next, so after this exercise, it's a servo motor after this. Maybe the camera on the floor.
Okay.
Are you? There's the camera there.
No.
I don't know if what we are saying over there like is getting picked up by the mic.
You want to ask them?
There's no one there.
Oh.
It's just recording for people who can make it.
Oh, okay. Right. You want to make a second? I'll take a look. Wait, where are these sites?
Oh, they're on mine. They're on the president account. I'm here to explain what an analog pin is, because now we're using the analog side. Why? Pretty simple.
Okay, good. But you got it.
Has everyone managed to plug their circuit? Yep. Okay. So we can write up the code.
So for some explanation, the serial does begin 9600. So that 9600 is basically the rate of that we're sampling. So usually we always put it to 9600 for. And you can see that we're using analog read this time instead of digital read. So with digital read, we had two values, high or low. With analog read, you can get a voltage value. So in this exercise, we get to see what changing the potentiometer can do to the voltage reading on the pin. And we're using a serial print, which means that you actually get the like the values printed on your computer.
It is the same as just printing to the terminal when you're writing any other code. Yeah, he worked with 230,000 for which, yeah. So those motors, lots of input.
Yeah. Have we worked that?
Yeah, okay.
Oh, nice. I think the biggest it goes to is 256, right? So, oh, no,
Yeah, that's
oh, hello.
what? Yeah, 0 to 1023.
Has anyone got it working yet? So with the analog read pin, the values that you get aren't actually the voltage, but it's going to be between 0 to 1023. So 1023 would mean it's 5 volts and 0 would mean 0 volts.
Yeah. Why is it 1002?
That's just it's
2 to the 8, 2 to the 10, right? It's 1023 because Arduinos, they are 10-bit microcontrollers. I guess that's like delving, well, what is it? Yeah, that's like going into the digital systems realm, but it's not necessary. Because 2 to the 10 is 24, and minus 1 is, yeah. So these Arduinos are more advanced than those early game consoles, like the 8-bit ones.
oh yeah.
but they're not as advanced as the 64-bit ones, like Mario Kart 64, the Nintendo 64. Yeah, they actually called that Nintendo 64 because it was the, I think it was like the first machine that ran at 64 bits. That's why it was like so popular, it was revolutionary.
Has anyone got it up?
It's like done specific thing, but sure.
Oh, your monitor is on your top right, there's like a button. the servo mode exercise, and then the pair task or the group task with the ultrasonic sensor, but it's already 6 or 7. I think we'll do both. So we'll finish around 6:45 or something. Oh no, I think what? Oh, how long do you think it'll take to put the pizza? 15 minutes. 20 minutes. Maybe what we can do is we start them on the ultrasonic sense.
And then we'll just bring him in, and then
No, we start the ultrasonic sensor, and then we go and get the pizza while they're working on it.
Yeah.
And then we bring the pizza back, and then they go ahead and explain what they've done. And then we eat, and we fix it.
Yeah.
Has anyone managed, or everyone managed to get it working?
We'll just wait an extra minute, and then we'll start on the next exercise, which is the servo motor. Yes. What happened? Oh, what was it?
So the next task is a servo motor. Hey guys, we're moving on to the next one. So servo motor, a normal motor spins 360 degrees, but a servo motor has a limited degree of motion. So it only spins 180 degrees and it stops. So the benefit of a servo motor is that they're very accurate. So because they have 180 degrees of motion, you can set the motor angle to any one of those 180 degrees and it'll be very accurate. And they are really strong as well. Benefit. So this is the code. So with servo motors, you can make things like robot arms like this. So you'd have a motor at the base that'll help the robot arm just rotate on the ground. And then there'll be another servo motor here that'll basically be the shoulder joint of the arm. And then you'll have one here that'll be the elbow joint. And then you'll have another one here, which is like the wrist. And then for the gripper part of a robot arm, you can also have another servo motor. And then this thing here, this is like a little humanoid robot. You can see there's a servo motor there, and there for like both arms and legs, and for the head or the neck. They're very useful. So this is how you wire up a servo motor. So this is modifying your circuit from the potentiometer. You're just adding the servo motor in and connecting it to the power ground to the power thing. I don't know, servo motors there.
You have to use pulse width controller on it.
No, that's done it. No, you have to do that, but there's a library that we use.
I don't think I've done it in the library.
It's pretty simple. It's a servo H mode library.
Oh, I mean, it would have been way easier.
Yeah.
Like,
Oh, in ESI.
yeah, I had.
No,
we
that's
had to do
no, that's because we had to like learn how pulse width
that's the only time I use it. Right.
But with the with the servo library,
Yeah.
you're literally just saying servo write, and then you write the angle, and it does everything for you.
Like saying when it reads potential low.
Yeah.
So when it reads a low voltage, then it does something.
Yeah, it basically maps the potentiometer value, the servo angle.
Oh, cool. Okay. Nice.
So from the potentiometer value 0 all the way until like 8 might correspond to angle 1 servo motor.
Oh,
And then 8 to 16 correspond to angle 2. Something like that. It's a mapping function.
okay. Yeah.
It's like because it's a scale, right? We just like, find a scale to the mapping each other. I feel like servo motors aren't. There's not that many benefits to them because they're not super accurate. They're accurate, but they're not. They're not they're not accurate as stepper motors.
Oh.
Or precise.
Are they easy to use?
They're very easy to use. Yeah, steppers are hard. They're heavy. They're big, bulky. Servo motors are light and small, but yeah. And And you can write decimal angles too. Yeah, so you can do like 1.5 degrees.
Yeah.
So I'm pretty sure it's possible.
That's good. I mean,
That's
color accuracy.
But there are like servo motors that you can buy that are really, really strong.
Especially. All the coloring.
So brown. Brown is, yeah, brown is the black, yeah, it's the ground. Red is power and then orange is the yellow is the Has everyone been able to wire it up?
I don't think so yet.
Yeah. We'll give a couple of more minutes. Time for code. Oh, where's code? Oh, yeah. So you want to explain the code one? For this code, usually if you would write the server mode code by hand or by from scratch, it'd be really complicated. But to make it easier for us, we're going to be using a library that's already been made for this task. So at the top, we do include server H, server library, and it's already in your the library that you downloaded. You download the Arduino IDE. At the very top, we create a server object, server my server. And then you have your potentiometer value part, and then you put in your angle, that's a variable. That's going to be angle of the servo motor. And then your pot pin, which is A0, your analog 0 pin. And then in your serve function, you start the serial monitor again. And then show the Arduino, which in our motor is on. So the data pin of the motor, which is the yellow one, that should be connected to N3. My servo attached N3. And then you go to your loop, you read the potentiometer value, you analog read, and then you display the value of the potentiometer, just like you did in the previous task in the serial monitor. So that the value equals the value. And now you have to basically map the potentiometer values from 0 to 1023, map all of that into the servo motor angles, which are 0 to 180 degrees. But then you use this map function, map the potentiometer value from 1023 to 0. You map it from 0 to 179. Yeah, you can't go to 180 exactly. Why is that?
That's just the rules.
Yeah, just the rules. And like the so that you can basically spin the potentiometer and that'll spin the servo motor.
Oh, very cool.
You wire it up?
Oh, yeah, sure. Not that, sure. Oh, we don't have enough time.
you should be able to like, they can play around with it. They can put numbers higher than that, but I think what happens is it doesn't go past
Right.
180. So it's just a 180.
Yeah, it's like that.
Yeah. Okay. So you feel free to play around and put like numbers bigger than 179. What might happen is that because it's a 180 server, it'll just go all the way to 180 and it won't go past that. So see what happens. I'm not entirely sure. Same with 0, you could put maybe negative number and see what happens. Like you won't break anything.
Yeah.
And you can brainstorm some ideas of how to input this in your designs for WhatHack.
For what hack, yeah. If you have any ideas, make sure to write them down so you don't forget.
Does everyone know the theme for WhatHack? Yes, wearable tech. Yeah.
I'm gonna make a Dr. Octopus arms.
Oh, I'm sorry. Wait, how do you get this up? Oh, wrong one.
Just there.
Whoa. Okay, let's
Standing here. You could have sat down, but it's just stand.
negative to ground. That's ground, right? What is that? Oh, it is. Which pin is that? In 3?
Yeah. The universal design come. Universal
sorry.
design strength.
Yeah, what about it?
So they try to move it to.
Oh, yeah,
So that means they haven't even booked the venue yet.
Ah,
Where are they gonna have it?
I have no idea. Honestly, I mean, we're just in it for the good times, aren't we? Oh, I miss it.
Shouldn't just force on moving it to Bible. They should just do it.
Also, maybe it's next year.
Okay.
Wait.
Okay, I have put in the code here. That's why.
Okay.
Where is it? I'll try.
Whoa.
There it is. Nice.
Mine works, everyone. Whoa. Men in Black.
Is it?
His son was definitely going that one.
His son.
One back
Oh.
No, they have like these ports, That's right. Out of your shirt. Oh, yeah. Oh, Greece comes in. Yeah. Watch this. Oh, just want run, put a bunch of resistors on.
Yeah.
Get it heating up. Yeah.
Just like, yeah, let's sure.
Running from the laptop or the tablet to warm you up. Oh my god, really?
Oh, yeah, you wrap it around.
Yeah.
Beach, like, cheap, like.
There'll be a judging criteria of that. Maybe that's a
Has everyone managed to get it working?
I think everyone's got to work, which is great.
Okay, let's go to the next part. So, oh, well, we have a Q&A session again, if anyone has any questions.
No question. Maybe a question is, who is this person who came in? What role are you in Newark? Yeah. Very important.
Officer.
Events officer, right? No, yeah, I didn't know. I'm just trying to clarify. Yeah. Okay.
At what time? Yeah. We'll look at an Arduino. All right. So now, next is if you were to, if you had to use an electronic component that you've never used before, what are you going to do? You can Google it. You can find the data sheet of it. Data sheet basically gives you instructions on how to use it, and it gives you sample code, so you can copy it and then play around with it. But if there's no data, if you can't find any guides online, then yeah, ask any others about it. Or sometimes there's online forums like on Reddit, where people have asked questions about them, and then yeah, there's answers.
Can we ask ChatGPT as well?
Oh, definitely, you can. I think you can even get the code from ChatGPT.
Yep.
Yeah.
Oh.
And for some complex electronics like the servo motor or what we're going to use next is the ultrasonic sensor, there's going to be libraries online for you to use it. So some people have already made, oh, no, these ones are made by the Arduino company, right? But for the servo motor, the library. Yeah. So the library just make it simpler to use them. and most of them are included when you download in the Arduino IDE, but sometimes there are user-made libraries on GitHub that you can download and then import into your Arduino IDE. And to install a library, that's an external library. So get the library as the zip file. You just download straight from GitHub or wherever, and it'll be a zip file and just import that. And then for any library that you download, to find example code, you just go to File and then Examples. So next, we are going to be looking at the ultrasonic sensor. So you will have one of these on your desk. So this basically, it's a distance, it measures distance through ultrasonic waves. Ultrasonic waves are sound waves, right? Yeah. So you can't see the waves. You just, well, you can't hear these either because they're ultrasonic, so they're at a higher frequency than sound waves that humans can hear. Yeah, you can measure distance with them. So you can make some kind of collision avoidance robot or a little car that avoids hitting things. And there are 4 pins on it. There's the power pin, 5 volts, ground pin, trigger pin, and echo pin. But you have to find out what they do in the next exercise. So here's a group task. So teams of 2. I think everyone's sitting next to.
Oh yeah, perfect.
Yeah, there's pairs. Yeah. Figure out how ultrasonic sensors work, and then make the circuit and write the code, and then see if you can integrate other aspects from today. So if you can put in the LED into there somehow, if you can combine their functionalities, maybe the servo motor or the potentiometer or switch.
See if it works. You can get the serial monitor out.
Yeah.
To see the distance that it's reading. And yeah, good luck, guys. So yeah, have a practice going online and checking out data sheets, because I'm sure it will come in handy during what hack as well.
Yes, yeah, definitely. These are really useful.
Yes. Wait, do we need 2 people or 3?
Um,
What if someone needs to stay back to switch the slide?
we want the 2 of us can go.
Yeah, stay.
No,
You 2?
no, we'll go, and then Ernest can stay.
Okay. Ernest? You mind like
You can laptop. You're gonna grab the pizza.
Yeah. How long? 20 minutes.
Yeah. Oh, wait. Oh, no. Okay. Oh, that's off.
Oh, are you reading this here?
Oh, yeah. It's like the way like yeah, it doesn't have a very thinking of like text or like it's like but it does work.
Your account, your account. With working here.
Okay. You can explain it right then. All right. We're going to wrap up this task now. Hopefully everyone got it working. So this is going to be an explanation on how ultrasonic motors work at a technical level. Ultrasonic sensors, yes. So you can see sensor has those two circles. One of them is a transmitter, so it sends out the sound waves, and then when you place an object in front of it, those waves bounce back, and the other circle we see is there. So the timing diagram, so you can see there are 4 pins to the ultrasonic sensor: the voltage, ground, trigger, and echo. So the trigger and echo are what does the actual measuring mechanics. So when you tell the sensor to measure distance, you put voltage into the trigger pin. So that's this.
Like a pulse, yeah.
It's like a pulse. I think the like most people use like a library, right? The library just does it for you automatically. But if you were to do it manually, you have to manually say write a voltage to the trigger pin, and then that transmitter sends 8 cycles of a sonic, so like a bunch of sound waves, like a one like
A lot of
pulses. Yeah. And then when it bounces back, the receiver receives the sound waves, and the echo pin outputs another voltage signal to say that, oh, distance has been measured. Right? How does it know what the distance is? How does it differentiate? Oh yes. Oh, that's true.
Thank you.
Between the input and the output, because the sound wave, they travel at like 343 seconds.
Oh, it's here. Yeah, perfect. Yeah, so that's the explanation of this. And we know that we're running close to the end of the thing. So
so this on the MUIC website. On the MUIC website, we have this blog. And last year we ran this series called Circuit Essentials, where we basically talked about small things about electric circuits, like what voltage, like a voltage divider is, or what a pull-up, pull-down resistor is, what an LED is. So this is something we worked with today, so LEDs, but this is a bit more of a technical explanation. If you're interested in that, if you're doing electrical, this is probably handy for you to know. So how an LED is a diode and how a diode works. All these and some equations related to it and how you integrate it into an electric circuit. It also talks about pulse width modulation, which we talked about with the
servo motors.
Yeah, servo motors run pulse width modulation. And then there's another one all about switches. If you are a bit confused by how switches work today, you can have a read of this. And it gives you like a very detailed explanation of how switches work. There's also another one about pulse width modulation, how a servo motor works. Like this. Yeah.
Hey,
All right. Thanks everyone for coming to the workshop. I hope you learned something, and I hope that you're at least a little bit prepared for what hack. If you could fill out the feedback form, that'd be very greatly appreciated.
yes. Thank you, everyone, for filling it out.
Yeah. Yeah. We'll put this slide back up, but before we go and have some food, there's just an announcement that MUEC is looking for committee members. So we are going to have our AGM, our annual general meeting, at the end of August. So when that happens, the current committee, pretty much everyone is leaving. And because of that, yeah, and because of that, we will be needing more committee members to keep the club running so that we can run more workshops like this, more hackathons like What Hack, and other events that we do. But because the AGM is at the end of August, there's still about a month and a half until then. We are currently looking for helpers for our events coming up. So this is like a great way to know what it's like to be in the MUEC committee, what we do as a committee. We have some events coming up called Elect Expo, the first one. So that is an industry networking night that we're hosting at the start of August. So just in about 3 weeks from now. And we're going to be needing some help running it in terms of organizing it and on the day. So if you're interested, you can reach out to us right now, or you can just message our socials. We also have an internship panel coming up. This is going to be a panel discussion event for anyone that's looking to get an internship. So we're going to have some students just like you who have completed internships, and they're going to be talking about what the application process is like, how to source them, what it was like interning at a company. Yeah, in the case competition, it's like a hackathon like What Hack, except you don't actually create something. You just come up with a plan or like an idea, and you flesh it out and you present it to a panel of judges. And then Super Hack, that we have that at the end of the year. Super Hack is MUEC's largest event, and this is like an engineering hackathon, just like What Hack, except it's for high school students. So that more specifically, it's for high school female and non-binary students to promote gender diversity in engineering. And we have university students like you as mentors for each team. You can have a look at, you can have a read of Super Hack more on our website. So you go here, there's a tab called Super Hack. Just click on it. And Super Hack is running again 2023, yes. And here's a little explanation on what Super Hack is and the motivation for it. And we actually ran this last year in November. We haven't updated that one yet, but we have this highlights video from 2019 that you can have a watch of. The highlights video from last year still hasn't been made yet, but it will be very soon. Yeah. Yes.
And yeah, please come to any of the other events.
Super Hack? Or what type of Super Hack?
32.
There's going to be 32 people, so 8 teams of 4. Yeah. Yeah. So if you're interested in joining the committee or helping us out at some of our events, just reach out to us. You can either come and talk to Michael or me, yeah, or Ernest, or you can email us or message us on like Facebook or Instagram or something. Yes, we're looking for more people. We need help. Let's go and have pizza now.
Come grab some pizza. The Santa